My name is Nawanga Afwa. We're working on a project about deep Q noise distillation for bovine respiratory disease detection in livestock. That's using multi strategy learning. So I'm going to go through our EDA code, the data analysis code for our project. So we started by importing the necessary libraries. That's the pandas, the NAPI, the seaborn, and the PLT, the Z score, and then the OS. To briefly go through these libraries, the pandas, this panda library, it helps, for easy reading, write, and process structured data. That's like, for example, the CSV files. Then for this NumPy library, for it, it supports large mathematical functions. Yeah, that's large mathematical functions in your data set. Then for the seaborn, the seaborn provides easy to use functions for making attractive plots. For example, this seaborn it's usually used when plotting heat map correlations, just like we're going to see as I continue. Then for this PLT library, it helps in, it's a plotting library that's used for interactive visualization. When I talk about interactive visualization, I mean it can combine the likes of pandas and NAPI and then have a visual, a clear visualization of a data set. Then for the Z score, it normalizes data. It normalizes data by computing the Z score of the data sets. Then this OS, the OS library, it provides functions for interacting with the operating system. Yeah, so if I'm to continue with the first data set, you can see print first few rows of the data set. This it simply means that the code goes ahead to print the first few columns of the data set, and then someone can simply get an overview of the data. As we can see here, the output, we can see the organism, isolate, the host here, then isolation, source collection, then the date, the year, country. Then as we follow the output, we can see the host, that's again the country, status, and then the clade. So our next code in the data analysis, we can see import pandas, then set pandas to display all rows. Then this simply goes ahead to print the entire data frame. So in simple terms, it displays all rows of the data frame and then prints the entire data set. So this is the output. As you can see, all the rows in the data set. You can see the sample, then the sample title, then the organism, just like you can see, it prints all of them. And the isolate, then the host. Yeah, then on the next code, that's the print summary statistics. This one, in simple terms, it goes ahead and prints statistics of the data set. When I talk about statistics, you can see the count, then the mean, like the count of the isolate, year, and the clade, then the mean of the isolate again, year, and the clade. Then this is the standard deviation, this is the minimum value. We can see the percentiles, then the maximum value. Yeah, so to continue with the next code, this is the this simply outputs the missing values. In simple terms, it goes ahead and checks the missing values in the dataset. Our output shows that in the datasets we can see isolation source has 4 missing values, then collection date has 8 missing values, the year has 8 missing values, then county has 2 missing values, province has 7 missing values, then the status has 24 missing values. To continue with the next code, it simply goes ahead and check if the data frame is empty, and then its data types. So in simple terms, it checks whether the data frame is empty. So and then goes ahead to give the respective data types. Here we can see that the sample title, it's an object, maybe isolate, it's an integer. For the year, it's a floating one, like the data type. Then the clade, it's also an integer. Yeah, so on the next code, we can see it simply goes ahead and check for respective data types still. As we can see, the sample, it's an object, isolate, it's an integer, then the year, it's a float, then the clade is also an integer. To conclude, we can see the plot, as I said, that this PLT library, it's used, it's a plotting library that's used to help during correlation, the heat map correlation. So to briefly go through this correlation, as we can see, it has the clade, yeah, and isolate, and in simple terms, this correlation, if you see a 1, it shows that's a strong positive correlation. If you see a negative 1, that's a strong negative correlation. If it's a 0, it simply means no correlation. But for these colors, if you see a red, it means that's a positive correlation. Then for a blue, it means that's a negative correlation. Yeah, that's my presentation.
Hello, my name is Dumba Jonah, and I'm going to take you through the EDA code for our model, which is handling the bovine respiratory disease, which is experienced on farms in cattle. So I'm going to start with the heat map. So this correlation heat map, this will show the correlation between like the numerical columns, and these columns we have the year, isolate, and clade. So the correlations like would be fairly limited, since there are only 3 numerical like the variables that we have. So and we have the samples that were collected between the year of 2017 and 2021, and so we have the years, the isolate, and the clade. So the sample identification number, so here we have the ones for the year that correlate with the years that correlate with the isolates, and also they correlate with the genetic groupings of the clade. And continuing further, we have the categorical count plots. So and these plots, we have the strain, the host, the province, the country, and also the status. And so these would show like so we have a count plot of the strain, and this one shows the distribution of IRE1 to IRE27, and also when it also shows let's see here, so it has from IRE1 up to IRE to 27, and also has that of Scott 1 up to Scott 5. So this count plot of strain shows the distribution of IRE1 to IRE2, IRE27, and also those of Scott. And going further to the count plot of host. So for this one, I would be this is just a single bar, as all samples are from the BOS Taurus, like the Taurus. So we go further, and this one is a 2-bar chart, and this one are mostly Leinster and Munster, while the some missing values are just a few. That's why it's like that. So this is the count plot of the province, and going further to the count plot of the country. So most Iran and with a few like Scotland samples. So here Iran, I mean, Ireland. So we have Ireland and Scotland, where we have the country against the count. And lastly, we have the count plot of status. The count plot of status, we have the status against the count. So this would show how many like samples were removed versus the unspecified count. And going further to like analyzing the missing values, being visualized. My colleague earlier explained about the missing values in the data. So here I'm just going to visualize the missing values using the heat map. And so we have the sample, have the strain, have the sample title, like the organism, isolate host, isolation source, collection date, year, country, county, province, host, tissue sample, and the country, and also the status. So, we have the missing data. So this heat map shows the missing data that we are missing from the data source that we have. So going further, we have the distribution of the BRD status. So currently we have I looked through this, but we have some missing data or information in our data source. So therefore it cannot draw this graph. And so going further, this code explains why the graph is not showing the plots. So the BRD status, this is not found. So the column the code tells us to check the column name because it is not found. That's why it cannot plot this status, because it is in the data we are missing. The status is not there. So going further, so the continuous features, we have the year, the isolate, and the clad. So we are below. I'm going to show you the box plots for those three. So if we have the year one, and the box plot is as shown below, and also we have the isolate box plot in the middle. This one is above. Mostly this is from 2021, from like 2019 2021, and this one it is an isolate against clad, and this one is the one for years. So, and also we have the one for clad, and this one only have a dot here at a clad of 2. So for if we go further to finding out if we have any outliers detected in our model, and therefore we have no outlier. As we see, we have 0. If I run it again, let's see, having an error. Let me just rerun the whole code. Therefore the code has finished running. So as I've explained below, the number of outliers detected in our code is 0. And if we go further to the collection date, so this could not infer format. So each element will be passed individually, falling back to like that to ensure a safe. So that's all for EDA. So thank you for listening.